Okay, so everyone have your unit circle out?
Yeah.
Okay. So on the unit circle up here that I have, it's not printed on your version, but on the one up here, notice how there are points along the edge?
Yep.
Okay. Each of those points actually stand for the cosine value and the sine value at that angle measurement. Okay. So a unit circle, what was the radius? The radius was what? 1. Okay. So the radius is 1. So if I go over to this point right here at 0 degrees or 360, what point is that on? It's 1, 0. Okay. So in your calculators, I want you to try taking the cosine of 0 degrees and then the sine of 0 degrees and see what two values you get. You got 1 and then you got 0. Okay. So the points along the unit circle stand for your cosine values and your sine values. The cosine values are always first and the sine values are second. A good way to remember that is alphabetical. Okay? C comes before S, just like X comes before Y. So cosine, sine. So we actually know 4 points on the circle already. We know the 0, 90, 180, and 270. So what point would this be up here at 90 degrees? 0, 1. Okay, what would the point at 180 be? Negative 1, 0. And what would be the point at 270? 0, negative 1. Now, do you remember when we did law of sines and law of cosines, and I said the sine function is incapable of finding obtuse angles? Do you remember that? So we had it for law of cosines. We had to use law of cosines to find our obtuse angles. That's because your sine values are your y values. In the top half of this unit circle, what are all of your y values? Are they positive or are they all negative? They're all positive. So the sine function isn't able to tell if you were over at 45 degrees or if you were over at 135 degrees because they have the same exact y value. Where the cosine function is able to distinguish that because one of them would have the negative x value and the positive x value. So what we're going to do is we are going to find these 3 points in our first quadrant. So we're going to find the points at 30 degrees, 45 degrees, and 60 degrees. So how we're going to do that is we're going to think of right triangles and geometry. So right here at this point on the unit circle, I'm going to envision dropping a line straight down and forming a right triangle. You might not want to draw it right on your unit circle, but we'll draw some triangles off to the side. So here, if you can envision this line happening here, if we can figure out the length, this bottom length, from here to here, that would be your x-coordinate, because that's how far over to the right you had to go. Then if we can figure out this other length, that would be your y-coordinate. So that tells you what your cosine value should be and your sine value. Okay? Do you know one of the lengths of this triangle already?
Yeah.
Which one?
1.
1 goes where? 1 is from here to there?
No.
Yeah, 1 is directly to the point. So 1 goes from the center to that point, so that has a distance of 1. That's the case for all the spokes. So we're going to draw that triangle out. So here's the point. There's my distance of 1. There's my 90 degree. And what angle measure did we say that first one was at? This says 30 degrees. Oh, what special right triangle has 30, 60, 90? Okay. So 30, 60, 90, how do the three sides relate to each other?
That's 2x.
Okay, so your hypotenuse is 2x. Your short side is
And that's x squared.
x, and your long side is x squared of 3. So if 2x is equal to 1 for our hypotenuse, x is a half. Okay, if x is a half, what is x square root of 3? we'd say 1/2 square root of 3, but we're going to write that as a fraction, so we're going to say square root of 3 over 2. Is that okay? Suppose? Is that just because of the 30, 60, 90, you don't remember much of it?
Who just labeled off all the sides?
No, you did good.
When you didn't know it.
Okay, we'll look again at it. So now, envision up to this point. So how far over from the center did we have to go? So how far to the right do we have to go? We have to go square root of 3 over 2, so that's your x value. And then how far up did you have to go to the point? 1/2. Okay, so check that.
Should we write that on?
Yeah, write that point on your unit circle. So check that. So this says the cosine value of 30 should be square root of 3 over 2. Now your calculators would spit out a decimal, so that one might be harder to check. But 1/2 we all know is 0.5. So why don't you try taking the sine value of 30 degrees and see, do you get 0.5? You get 0.5. Okay? Is there another triangle on here that would use the 30, 60, 90? Which angle? The 60-degree angle would use that same triangle, right? Okay, but what would be different? So I'm going to draw that one right here. So this is 60 degrees. Our radius is still 1. So think about your 30, 60, 90. So your hypotenuse is still the 2x, but now where's the short side? Where's your x on this? The x is the bottom section, and the longer leg is the x square root of 3. So if 2x is equal to your hypotenuse of 1, what does x have to be? 1/2. And so on your longer leg will have to be what? Yeah, square root of 3 over 2. So now what would be the point at 60 degrees? How far over to the right would we have to go? Yeah, we'd have to go 1/2 to the right. And then how far up do we have to go? How far up would we go? Square root of 3 over 2. Now, do you also remember from the first day we talked about right triangles, and we did sine, cosine, and tangent of our angle A's and our angles B's, and we noticed that the sine of A and the cosine of B are the same value. Okay? That's what's happening here. 30, 60, 90s. Our sine of this angle 30 is the same value as our cosine of our angle 60, and vice versa. So how would we figure out 45 degrees? Yeah, the 45, 45, 90 triangle. Okay, so here we are going up to the 45 degrees, radius of 1. Okay, so your hypotenuse is x squared root of 2, and what are your two other legs? X and X. Okay, so that's your 45, 45, 90 triangle. So how do we figure out what x is? So here we have our hypotenuse tells us that 1 is equal to x squared root of 2. So how would we figure out what x is? Divide by the square root of 2. Okay, so now we have 1 divided by the square root of 2 is x. How do you get that so that it's simplified? So what did you do to get that? Okay, multiply by the square root of 2. So you have square root of 2 over 2. Are these two like values the same? So how far over and up would we have to go for this? We'd go over to the right how much? Square root of 2 over 2, and then we would end up going up square root of 2 over 2. One of the problems that you did just now, number 7, you went over square root of 2 and down square root of 2. So that was a 45, 45, 90 triangle, and you should have gotten this value for your sine and that value for your cosine. And you did. So now we're going to use this to find exact values. So how this works is we are going to, thank you. So we're going to draw the angle measurement in. We're going to sketch the reference angle. And then we're going to look at our unit circle And if we're asked for the cosine of 30, we're going to go, okay, well, the cosine of 30 should be square root of 3 over 2. If we're asked for the sine of 30, well, the sine of 30 should be a half. Okay? So, we are going to find the sine of 330 first. So in order to do this, we have to find its reference angle. Always dealing with the reference angle. So we're going to start by sketching it just like you were doing right towards the end. So 330 degrees, where would we sketch that angle? Right where? In the fourth quadrant. Okay, so that's 330. That's 360, so what's our reference? 30. Okay, so we're going to look at 30 degrees. Okay? And then the other thing we want to think of is your sine values. Those were like our y values. So down here in the fourth quadrant, what types of values are our y values? Are they positive or are they negative down there? They're negative. So we're going to have a negative answer. And the sine of 30 degrees, so here's 30 degrees. Cosine value, sine value. So our sine at 30 is what? 1/2. So we'd say that this should be negative 1/2. It's negative because our reference angle, when we sketch that angle, it's down in the fourth quadrant. Sines are in the y position. All of your y values in the fourth quadrant are negative. So it would be a negative.
So how did we get that? I'm confused on this whole thing.
How did you get which part?
No, the answer.
Okay, so did you follow to 30?
Yeah.
Okay, so now look at your unit circle. Go to 30 degrees. What's your sine value at 30 degrees? Well, this says cosine sine. So which one is your sine value? The 1/2 is. And we decided it was negative because in the fourth quadrant, all of our y values are negative. Okay. Let's do secant of 450. Okay. So 450, if we try to sketch that reference angle, how would that look? Okay, so it's going to overlap. So it's going to go around one full time, right? And then how much more? Well, what's 450 minus 360? 90? So it's going to go all the way up to that 90 degrees. So what's your reference angle there? What's the difference between 90 and 0? 90 is our reference angle. Okay. Secant, it's the reciprocal of which one? Cosine. Good. So we're going to look and see what the cosine of 90 is. So go to your unit circle. 90 degrees. So here's 90. What's the cosine? 0. Okay, the cosine of 90 is 0. How do you take the reciprocal of 0? Yep, the reciprocal would be 1 over 0. Can we divide by 0? Nope, so we're going to call this undefined. Is that one okay? We're going to do this one right beneath it next. Cosine of 5 pi over 6. Okay, so cosine of 5 pi over 6. We need to do the reference angle first. So 5 pi over 6. So there's our reference angle. So what do we need to compare it to? Pi. So 6 pi over 6. So what's the difference there? Pi over 6 is our reference angle. So we want to look and see what the cosine of pi over 6 is. So on your unit circle, find pi over 6 right here. And then what's the cosine value there? Square root of 3 over 2. Now what would your x values be over in the second quadrant? Would they be positive or negative? Your x values would be negative. So what are we going to make this? So we'd say negative square root of 3 over 2. Does that make sense? I mean, it's using the unit circle to find the right measurement.
Go back to the time.
So the what?
Circle. Just for a second. Okay, got it.
Okay, cosine sine. All right, so tangent. Tangent of 150. Oh, we can find the reference angle for sure. So to find the reference angle, we do between 150 and what? 150 and 180. So what's that angle? 30. Okay. Now, tangent, is that on our unit circle? No. So we're going to do a little side work so I can show you what tangent is equal to. So SOHCAHTOA. Sine says we are opposite over hypotenuse, right? Cosine says adjacent over hypotenuse. And tangent says opposite over adjacent. Tangent, I'm going to argue, is really sine over cosine. So if I take sine over cosine, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. How do you simplify a fraction divided by a fraction? Multiply by the reciprocal. So this is the same as opposite over hypotenuse times hypotenuse over adjacent. So what happens to your hypotenuses? Cancel, and you're left with opposite over adjacent, which is tangent. Okay? So if you want to find tangent, anytime you want to find the tangent of theta, you just have to take the sine of theta and divide it by the cosine. Okay? So, okay, maybe don't talk while we're doing examples then. All right, so we're going to find the tangent of 150. So which means I need to find which two values to do that. I need both the sine and the cosine. So we already decided the reference angle was 30. So go to your unit circle at 30 degrees. So here's 30. What's the sine value at 30? 1/2. What's the cosine value? Square root of 3 over 2. So tangent of 150, we're going to take the sine value and divide it by the cosine. So sine is 1/2. Cosine is square root of 3 over 2. How do we simplify when we divide fractions? So multiply by the reciprocal. So it's 1/2 times 2 over square root of 3. What happens to your 2's? Cancel. So you're 1 over the square root of 3. How do you simplify that? So how do you what did you do? Multiply top and bottom by square root of 3, so you get square root of 3 over 3. How do we decide if this is positive or negative then? So in the second quadrant, what are your x values? Negative. What are your y values? Positive. So one of these was negative, the other one was positive. So what would we get as an answer? A negative number. If they're either both positive or both negative for tangent. Okay, so that's using your unit circle.